Good morning. My name's Steve Horton, UK Technical Manager for ICO Road, and I'm here to guide you to the various applications of the world's most versatile asphalt material. So in the UK, there's a handful of mastic asphalt manufacturers. Some offer specifically asphalt repair systems. Some primarily offer car parking and waterproof systems. But we at ICO supply the full spectrum of mastic asphalt products and systems, with a division focused specifically on supplying to the highways and civil sectors. Mastic asphalt has been used extensively throughout the UK, but still probably has minimal awareness from the wider highways sector as to the product's nature, application, benefits and capabilities. This presentation will hopefully give you all a greater awareness of mastic asphalt and its uses. Mastic asphalt has been used as a waterproofing system for hundreds of years, since the days of the early ancient Phoenicians through to waterproofing Francis Drake's ships. The Victorians used it to waterproof bridges and buildings such as St Paul's Cathedral and the Houses of Parliament, and right up to the modern day, mastic asphalt has been there keeping water out. Historically, from a highways point of view, mastic asphalts have been used primarily on bridges, with projects such as Tower Bridge, the Erskine Bridge, Tamar Bridge, plus numerous other smaller bridge projects, including lifting and swing bridges. So what is mastic asphalt? Well, the textbook definition is it's a type of asphalt composed of suitably graded mineral matter and asphaltic cement in such proportions as to form a coherent, voidless impermeable mass, solid or semi-solid under normal temperatures, but sufficiently fluid when brought to a suitable temperature to be spread by means of a hand float or an appropriate machine. Mastic asphalt paving grades used on bridge decks and car parks are typically gap graded, containing coarse aggregates in percentages of around 25 to 45% coarse aggregate. They're typically manufactured by mixing bitumen additives and fine aggregates to create a base mastic on a specialised mixing plant, and then the coarse aggregate is added as a secondary process. Paving grades are covered by BSEN 13108 Part 6 and should be UK and RCE marked, and waterproofing grades are covered by BSEN 12970. Mastic asphalt differs from other bituminous highway materials as compaction is not required, and the material relies on the binder itself to provide the strength and resistance to deformation. Therefore, mastic asphalts typically use harder grade bitumens such as 1020 and 1525 pen, along with other additives such as Trinidad Lake asphalt and other specific polymer modification. As mastic asphalt is impermeable to water, it's inherently more durable than other bituminous materials where water can penetrate and cause issues such as binder stripping and freeze thaw. Mastic asphalt as a primary waterproofing has been historically used under mastic asphalt bridge surfacing and car parks, and again that material complies to 12970. Waterproofing grades do not contain coarse aggregate, but are normally 3 mil in size and have binder contents typically in the range of 12 to 14%. Mastic asphalt bridge deck surfacing again complies with BSEN 13108 R6 and PD 6691. It can be installed either by hand or using specific mastic asphalt paving machines. BS 594987, which is currently under review, will contain an annex specifically for mastic asphalt. Typical installed thicknesses are around 40 mil, and as there's no requirement for compaction, as mastic asphalt is voidless and self-leveling. Testing for mastic asphalt involves standard grading and binder content. There is a specific test called the indentation test, which is unique to mastic asphalt. It consists of a standard load of 525 newtons applied to a retained sample at 40 degrees with typical indentations of less than 4 mil. Wheel tracking, ISTM, etc. are all tests which can be done, and mastic asphalt holds up to most surfacing materials. Typically, in terms of bituminous bridge deck expansion joints, standard flexible plug joints or APJs have been installed. These are basically graded aggregate installed in layers into the joint with binder poured in to fill the voids. These systems are, although very flexible, they can provide significant deformation. Mastic Asphalt as a system where you, as a typically very high modulus midsection, labelled 1 on the diagram, which provides the rubbing surface and the resistance to deformation. The movement of a joint is provided by sections of high flexible bituminous compound to either side, and typical expansion joints, Mastic Asphalt expansion joints, provide up to 40 millimeters in total movement. Where full depth pavement reflective cracking occurs, an inlaid crack material system would typically be installed up to depths of around 40 mil, but can go full pavement depth if required. Again, flexible bituminous compounds are used to interface with the existing carriageway to provide flexural movement and adhesion to the existing substrates. The inlaid crack repair is impervious to water penetration and allows for flexural movement, therefore providing a durable repair where reflective cracking is prevented from propagating into the pavement surface. But Mastic Asphalt can also provide other wide range of asphalt repair systems.
And it's here with all that
surface cracking and spalling, where a patch repair or overbanding application would typically be used. A Mastic Asphalt with maximum 3 mil coarse aggregate applied by means of a heated shoe directly over the crack, and then a application suitable anti-skid over the surface. Very quick and easy to install, and due to the thin application and rapid cooling, can typically be trafficked shortly after installation. We've found with our systems that trafficking can be in as little as 10 minutes after application. Localized repair systems are primarily for pothole type damage to the carriageway. The damaged area, once suitably repaired, is tanked again with a flexible bituminous compound, and then the high modulus Mastic Asphalt is installed into the pothole and the surface treatment applied. Probably the most common application for Mastic Asphalt in highways is ironwork repair and reinstatement systems. Due to Mastic Asphalt being impervious to water, it is well suited to counteract the typical modes of failure encountered in ironwork systems. Mastic Asphalt has been developed to provide a quick and easy installation system with long-term durability. Systems such as our ICO Paco Patch ironwork system employs a combination of Mastic Asphalt grout in conjunction with pre-formed mastic bricks, which embedded in the ground assists with the cooling of the installation. And when used in conjunction with synthetic ironwork, can provide solutions that can last well in excess of 5 years. Mastic Asphalt can also be used in transitional systems, such as tram rails, where vibrations can cause premature braking in your button carriageway. A similar principle is employed for expansion joints, where the inlaid crack repair and local systems, in that a flexible binder compound, are used to mitigate vibration through the ironwork, with the Mastic Asphalt providing a durable, water-resistant transition to the surrounding carriageway. It's also worth briefly mentioning car parks as another application for mastic. It's probably one of the largest uses of mastic in the UK, with the asphalt system, and provide a thin, waterproof and durable running surface for the car park, ideal for multi-storey and podium deck applications. So in summary, I think the consistent theme throughout the presentation is durability. And it's this durability that makes Mastic Asphalt so versatile within the road construction industry. As the wider road construction community has come round to the conclusion that water penetration within the pavement is a major contributor to premature failure, Mastic Asphalt as a product has been installed over the last 60 years for that exact purpose, to prevent water ingress. We at ICO, as part of the road construction industry, have to take some of the responsibility for not promoting Mastic Asphalt as extensively as we could have done. But as you can see from this presentation, Mastic Asphalt has perhaps come full circle based on its inherent properties of versatility, durability and ease of application, to be classed as a modern pavement option with its varied applications. Here at ICO Road, we are always looking at further developments and uses of Mastic Asphalt on highways and developing these within the scope of associated accreditations. With the dedicated R&D function, we are not resting on our laurels as we continue to push the boundaries of innovation, sustainability and product performance. I'd like to thank you all for attending, and obviously if there's any questions, I'd be happy to take them now, or you can find us at the stand outside.